in this session, we are going to see how we can basically make assemblies. So for that, we'll construct small parts like we did in the previous videos. So let's just select the plane first, right plane, top plane, front plane. Um, Maybe just go with top plane this time, and I'll choose sketch. I'll choose a rectangle. And this is plain 2D sketch that you have. Okay, the way I'm able to rotate this is by clicking the um is by basically pressing the scroller of my mouse. If you can see this in the camera, and that's how I can just rotate it anyway. Now I'll uh, select features, extrude boss base, and mm, let the height be, for example, 15 mm. Okay, we have 15 mm here, and we just click OK. Okay, so we have made the first part. We'll try to save it. Okay, Control S. I'll just paste the location in my laptop where I need it. So I already have something called part 1 from my previous video. I'll make it as part 2. I'll save it. Okay. Once this is done, I'll just close this file. We'll go to the file section, new, again a part. Okay. We'll make one more sketch. Let's say, mm, we'll choose right plane, and then maybe a cylinder. So we'll take a circle. Let's take our origin as the center. Okay, take a radius here. So we'll go by smart dimension and define the diameter. So this is 40.26. So our cuboid was 15 mm. We'll try to make it smaller than that so that this cylinder fits into the thickness of the cuboid. Okay, so we'll make it, let's say, 10 mm radius. Okay, so now the diameter. So the diameter is 10 mm. I'll just get out of this sketch. Click the sketch once again, go to features, extrude boss base, and define the height. So maybe for now I'm taking an arbitrary height, which can be 48 mm. Okay, so this is how my cylinder would look. Okay, now the cylinder is created. Again, Control S. Um, I have the file location. I'll choose part 3, save. Okay, so now I have this as part 3 here. What I'll do is I'll just close this. I'll go to file. I'll choose new. Now this time I'm going to choose assembly. Once I choose assembly, you will see a few different things happening. Firstly, insert components. Okay, so the dialog box opens automatically, and once you choose a part here and click open, it will get listed here, and then you can tick the green marker here, and the file will be available in your main screen. So I'll go by scratch. I'll close this. I'll close this. Okay, so let's say if you don't get that dialog box automatically, what you're going to supposed to do is go to Assembly tab inside this SM1. Okay, click Insert Components. Now you have multiple ways of inserting components. Okay, what we are going to do is rather than creating a new part, we already have parts created and we are going to just insert those components. So I'll click Insert Components. The same dialog box opens. Choose your file location wherever you have kept your files. And now we are going to choose the parent part. So the first part that you are going to insert into this becomes your parent part. That is, its position in space remains fixed. So when I say that, let me choose part 2, which was our cuboid, as the parent part. Okay, I'll click open. So here we have this. I'll just click it here, it gets placed. Now, when I say this is a parent part, what it means is that I cannot move it. Just by left clicking my mouse and dragging it here and there, I won't be able to move it. This has got a fixed position in space, in this 3D space. it's fixed. To make it move, I'll have to go right click, open this menu and click float here. Okay. Once I click float, let's see what happens. Now I'm able to drag it in space. Okay. So I'll fix it back again. I'll try to insert my other component. Insert components again. Insert components. I'll choose part 3. Open. So part 3 will come here. I can drop it anywhere. Now once I have dropped it, I have to mate it in a certain orientation. Okay. So let's say I want this face to be mated to this face, but it's yeah, but if you can see the direction of this face, it's parallel to my target face. So what I'm going to do is turn it into turn the face towards my target face. So how am I able to do it is there are two ways of doing it again. Either right click my so basically in this mouse, I'll right click my mouse button and drag it. Okay. So when you right click your mouse button and drag it and drag your cursor, the shape or the part that you have created follows accordingly without changing its position in space. Okay. So this is how you're able to move it slightly. The other way is basically click it here. It's a single click, right click. Now you have all these plethora of options, and now you have move with triad. This triad helps you rotate this part 360-degree in all orientations. Okay, if you want to move it in this orientation or in this orientation. I hope you're getting the plane in which you're moving, right? When you are rotating, this is one plane. When you are rotating it this way, it's the other plane, okay? So, and another orientation. So there are 3 degrees of freedom. You already know that. So this is how it is. So I'll choose the easier one out for me right now, which is right clicking the mouse button, keeping it clicked and dragging my cursor along. Now I have my face of the cylinder towards the target face. Okay, so mating is pretty easy. I'll click the surface. Now I'll press Control button on my Windows keyboard and click the target surface. Fine. So there's this mate option. I'll click mate. Okay. By default, whatever mate is applicable will get selected here automatically. So coincident mate is applicable. It got selected as this is the closest mate. Even parallel mate is possible where this face remains parallel to this face. So this is parallel mate. Okay. And then this is perpendicular mate, the one that we had in the previous orientation. Tangent and concentric are not applicable to it, hence they are not highlighted. I'll go with coincident mate for now. Now you see this as attached. There's one more feature within this coincident mate, that is, for example, if you want to have these features at a certain specific distance or an angle, what you can do is select distance. If you click 5 mm, so now when you tick it, there will be a perfect distance of 5 mm between this face and this face, and it will remain locked. It will move all along this face, but not without reducing this gap, okay? All through the space. So this is where you can change the this is where you can change the change the distance between two objects. You can choose 0, which will be basically nothing but the actual coincident option. Okay. So let me just get out of this distance and get back to the original coincidence feature. This is how it gets mated. Okay, I'll click tick mark. Now just observe that however much you move it, this face is never going to cross this boundary. Okay, this boundary. It will always be stuck to this face, our target face. Okay, wherever you move, however you move. Now you want to constrain its position. Okay, you don't want this feature to move all along. You want it to be stuck here at a certain location. Okay, so what else can you do? For So what we will do is see, I'll select this. I'll show you something which is also which might also be new. So if I have to choose this, or maybe lock the top and bottom motion, what I'm going to do is choose the plane that is perpendicular or parallel, one plane. So within this part, it has three planes, right? This is the front plane, the top plane, and the right plane. Okay. Now just imagine if I choose this top plane and I choose this surface. If I make the top plane parallel to the surface, given the circular nature of cylinder, nothing will get affected, right? So let me just mate it and show you. Okay, so again, the coincident mate was the most close mate. That's why it got applicable automatically, but I don't want to fix it here, at this height. So I'll just choose parallel, which will make my surface parallel to this mate. Okay, I'll click OK. Fine. Now what you will see is that you won't be able to rotate it in along this axis. If you see this line as an axis, you won't be able to rotate your part about it. Why? Because then the top plane would have to rotate, which is here. And since you have constrained it with the mate such that it has to be always parallel to this surface, this will never move. This will never change its angle. So now this is constrained within its own axis of rotation. So this is one thing. Now you have two constraints. First, the top plane will always remain parallel to this. Second, that the distance between this plane and the target plane will always be zero. What you want to achieve is that uh, the top of this cylinder remains at a particular distance from the top surface of this cuboid. So what I'm going to do is simply take this again. Now I know that it's the top plane that is parallel to this. Okay. So this is press control, choose the surface again. Okay. Click mate. Now within coincidence, if you remember, I talked about distance mating. So if this height is 15 mm, the diameter is 10 mm. Sorry, the top plane has been constrained parallel to the top surface of this cuboid. Okay. So now I can assign a distance to this uh, top surface of the cuboid and the top plane of our cylinder, right? So I'll just select the top plane on this very surface. I'll click once again, pressing Control button. Now two planes get selected. I'll go with mate. Okay, you see here. Now let's say I take distance. Um, let's say I press 10. Okay, so now the distance between the center of your circle along which this top plane actually goes will be 10 mm away from the top surface of the cuboid. Let's check it. Okay, I'll just take it, cool, fine, you see. Now what happens is there, if I have to check this, I'll choose the circle, I'll choose this line and press M on my keyboard. Okay, or if, if that's not the shortcut that works for you, you can actually go to evaluate, click measure, and you will see the distance along dy as 10 mm right now. You know, uh, this is the one between the top surface of the cuboid and the center of your circle, along which the top surface or the top plane of your SolidWorks was aligned with. Okay, I'll close this. So you have seen how it works. Now you have constrained it along the height of the cuboid. Okay, so for now, what we can see is that the cylinder cannot cross this boundary, cannot move away from this boundary because you have placed a coincident mate. This particular cylinder cannot move up or down because you have constrained the height to be 10 mm of its center from the top surface, but this can still move along the length of this cuboid. Okay, so what I'm going to do is try to constrain it along this as well. Let's see if I can draw a plane here and constrain it. For uh, geometry, if the top plane and the front plane are perpendicular to each other by default, and top plane is parallel to this plane, the the front plane will automatically be perpendicular to this plane as well. And this plane and this plane are perpendicular. So this plane and the front plane will be parallel. Okay. So this helps me in defining the distance between the front plane, which is parallel to this plane, So what I'll do is, let's say I want to place it somewhere, um, 15 mm from this surface. Okay. So I'll select the surface, press Control, press front plane here. Now I have this front plane and this plane. I'll go to assembly, mate. Again, the coincident mate applies by default because it's the closest mate that is applicable. So I'll choose distance. I'll choose 15 mm. I'll press OK. So now this front plane, which is passing along the center of the cylinder or the center of the circular face, is 15 mm from this surface. I'll click OK. Now understand one thing. What it means? It means that the center of this circle will be placed 15 mm from this surface. So if I have to check that, I'll go to evaluate, I'll click measure, I'll click the surface, I'll click the boundary of the circle so that I can find the center distance. I click the boundary of the center and you see the center distance is 15 mm. Distance of center from this, exactly what I defined. What is another observation that you will see is this is not able to move at all because y- regarding the distance along the z-axis, you have already constrained it to stay attached to the surface. Okay, so neither it can move, neither the cylinder can move away from the surface nor into the surface. Okay, so one constraint. Second constraint you placed is that this center of the cylinder or the uh, circular cross section of the cylinder is supposed to be at a certain distance from the surface, so it cannot move to and fro. Okay, by putting the top plane parallel to this, you have fixed its rotation. That this cannot rotate, otherwise the top plane will change its angle along against this. But you don't want that to happen. You have constrained it to parallel, so the angle remains 0 degree, so it cannot rotate. These are the three constraints you have placed. So for the fourth constraint you have placed is placing this front plane again, which passes through the center of the or the axis of the cylinder at a distance of 15 mm from this surface. So it cannot move in the x direction, either away from the surface or towards the surface. So this is how an assembly is built, by placing constraints over the motion of parts. And I hope you enjoyed this video, and I hope that you got much more clarity. Okay.